Hello, grade 12s. We are starting chapter 4, which is all about trig and the unit circle. Our first outcome is really quick, and we're going to start with some prerequisite knowledge. So if you could please complete the handout attached to your note booklet. The Google Classroom has all of your answers, so just go through that, help each other out, and work through the problems. Then we're going to take down the notes for section 4.1. So please start by copying down the following definitions. Pause the video here to copy down your notes. So let's talk then about what a radian is. So a radian is the measure of the central angle, and central angle means here this angle in the middle, when the arc and the radius are the same length. So the arc is this part right here, that's the arc. And then the radius, we know what that is from the center to the outside of the circle. So 1 radian is when the radius and the arc are the same length. We're also going to talk about coterminal angles. So here's an example of a coterminal angle. You could have a 60-degree angle, but if I'd go all the way around the circle again, we'd be at a 420-degree angle. So 420 and 60 would be coterminal. So basically every time you add or subtract 360 degrees, you'd get coterminal angles because the angles would fall right on top of each other. Then we have general form. General form is just an equation representing all possible cases. So let's talk a little bit more about this radian. How many radians do you think it would take to make up half of a circle and a whole circle? Pause the video here and discuss. So I'm hoping that you thought about 3 radians would make up a half a circle, so then about 6 radians would make up a whole circle. Now actually it's not quite 3. It's actually a little bit more than 3, and then it is a little bit more than 6 as well. So what numbers do you know that are a little bit more than 3 and a little bit more than 6? Well, I hope you're thinking pi and then twice pi, or 2 times pi. So again, halfway would make up about pi radians, or not about, exactly pi radians. And then the whole way around the circle would make up 2 pi radians. If you do that conversion, or if you take 360 degrees and divide it by 2 pi, because I know that 2 pi radians go around 360 degrees, you'd get that each radian is approximately 57.3 degrees. So every radian is approximately 57.3 degrees. Now let's fill out some notes with that. Alright, here's your next set of notes. By convention, angles measured in a counterclockwise direction are said to be positive. So that means if I start at the x-axis and go counterclockwise, that would be a positive angle. But if I start at the x-axis and go clockwise, that would be a negative angle. We already said that 1 full rotation would be 2 pi radians, so then half a rotation would be pi radians, so then a quarter of a rotation would be pi over 2, and an eighth would be pi over 4. So if you just keep cutting that 2 pi, just keep cutting it in half, you'd figure out all of those. This part's very important. If you're given an angle without a unit, that's how you know it's in radians. So there is no unit for radians, it just doesn't have a unit, and then you know it's in radians. So how many degrees would 1 radian be? Well, we already said that if you take 360 degrees and you divide it by 2 pi radians, that would give us 57.3 degrees approximately. So 1 radian is approximately 57.3 degrees. Let's look then at converting between degrees and radians. So to convert between them, we can use a little conversion factor. Basically, we're going to take 180 over pi on one side because those two things are equal to each other. 180 degrees is equal to pi radians. And then we'll set up the other side with whatever information we're given. So for our first question here, we are given 30 degrees. So we'd go 180 over pi equals 30 over x. So I just have to make sure that my degrees are paired on top with my degrees, and my radians are paired on bottom with my radians, and then we cross multiply. So I'm hoping that we remember how to cross multiply. This would be 180 times x, and then equals 30 times pi. Now the trick is that we want all of our answers to be exact if possible. So we would divide out the 180, and we're going to keep this as a fraction. So we'll end up with x equals 30 over 180, but 30 over 180 can reduce to 1 over 6, and the pi would go along the top with the 1, so it'd be 1 pi over 6. Now think about drawing that, because it also says we want to draw each angle in standard position. So a standard position angle starts on the x-axis, and here we're talking about a 30-degree angle, so it'd be something like that. Make sure you include your little arc here to show the angle that we're discussing. All right, let's try C together. So for C, we'll set it up as 180 over pi equals x over 5 pi over 4, and then cross multiply. Now when we cross multiply, we're going to want to keep this 5 pi over 4 as a fraction. So on one side we have 180 times 5 pi over 4 equals pi x. Now here we have pi on both sides. So you guys, the pi is equal on both sides of the equation, so we can cancel it out or divide out pi. Then all we're left with on the one side here is x, and on the other side we have to go 180 times 5 divided by 4, and so we'll get 225 degrees. Now it's easier to draw when it is in degrees, so when I think about drawing this, 225 degrees in standard position would be somewhere in quadrant 3, and again draw your arc to show where it would go. Please try B and D on your own. Pause the video here, and then we'll compare answers. Compare your answers with those on the board. Let's go then to example 2. In example 2, we're determining a positive and a negative coterminal angle for each of these angles, and then we'll determine in which quadrant each one lies. Now the quadrant thing we could probably do first, because a 40-degree angle would lie here in quadrant number 1, so we'd have a 40-degree angle here in quadrant number 1. Now if I want to find the coterminal angle, I'd have to add 360 degrees. So when I add 360, I end up with a 400-degree angle, because 40 plus 360 is 400 degrees. But if I want to go the negative angle, I'd have to go backwards, so I'd subtract 360. So when I subtract 360, we'd get a negative 320-degree angle, which would be my negative angle. So we need one positive angle and one negative angle that are coterminal. All right, now let's think about B. So B is a negative angle, so I'm going to start at the x-axis and I'm going to go backwards, or I'm going to go in the clockwise position. I'm going to go past 360, and I'm going to go a total of 70 degrees past 360. So my angle, again in the negative, would go all the way around and then back to there. So that's a negative 430-degree angle. So if I want to come up with another negative angle, in this case I could actually add 360 because it's more than one loop around. And if I add 360 degrees, I'm going to get negative 70 for my negative coterminal angle. But if I add another 360 degrees, we would get a positive 290-degree angle. So again, I'm just adding 360, but I'm adding it twice to get out of the negatives. So that would be how we get those two values. Now let's go to part C. C is going to be the trickiest because it's in radians. So when I think about 8 pi over 3, I'm going to compare that to one whole loop around the circle. And remember that one whole loop around would be 2 pi radians. And if I get that with a denominator of 3, that would be like 6 pi over 3 radians. So that means 8 pi is more than a full loop around. And so it ends somewhere in quadrant 2, because 9 pi over 3 would be over here at the pi marker. So we're looking here in quadrant 2. Now what we need to do here is we need to add or subtract 6 pi over 3, because 6 pi over 3 is one full loop. So if I start with 8 pi over 3 and I add 6 pi over 3, we should get 14 pi over 3. Now that could be one of our positive ones. So let's try subtracting 6 pi over 3. When we have 8 pi over 3 and we subtract 6 pi over 3, we end up with 2 pi over 3, which is still positive. So I could list either 14 pi over 3 or 2 pi over 3 as my positive coterminal angle. But if I subtract another 6 pi over 3, then I get to my negative coterminal angle, which could be negative 4 pi over 3. So there should be an infinite number of positive coterminal angles and an infinite number of negative coterminal angles, as you would keep going around and around the circle. Now let's try general form. So if I'm starting with 110 degrees, and I want to figure out in general form what these angles are, we would basically be adding or subtracting 360 degrees times n, and n represents any natural number. So now let's just look at what would happen if we plug in different numbers for n. So for example, if we'd subtract 360 once, we'd get to minus 250. If we'd subtract 360 twice, we'd get to minus 610. And if we'd subtract 363 times, we'd get minus 970. Same thing here if we add it. Add it once, you get 470. Add it twice, you get 830. Add it 3 times, you get 1190. But we want to just focus on the domain between minus 720 and positive 720. So when I look, the only ones that fit that domain are these 3 values. Let's do the same thing now with radians. So we have 8 pi written in general form. When it's in radians, we have to add or subtract 2 pi and then n. Again, n represents the natural numbers. So again, since I'm in radians, I have to go with 2 pi because that is the distance around a circle there in radians. Now we're going to look for the domain minus 4 pi to positive 4 pi. Now this domain's a little bit tricky because when I go to look at which ones actually fit, it's only the 2 pi, 0, minus 2 pi, and minus 4 pi. Notice that there's only an equal to with the negative 4 pi, not the positive 4 pi. Pause the video here if you need to copy that down. The final thing for today is we need to look at how to use this formula to calculate arc length compared to the angle and the radius. So look at this little diagram here. The angle has to be in radians. And then if you're thinking about how this works, if the angle is 1 radian, that would be A equals 1 times R, which means A equals R. And by definition of what a radian is, the radian is when the arc equals the radius. So this should make sense. Here we've got example 4. Basically this engineer is looking at making a decorative arc below the on-off button of a DVD player. The arc has a central angle of 130 degrees, so my angle is 130. The radius is 6.7 millimeters. We want to find the arc length. So we're going to use our formula A equals the radians times the radius. So first we need to convert 130 degrees to radians using our little formula from before. So when we convert that, we should get 2.27 radians, and it is okay that we use a decimal here because it's saying that it wants this answer to 1/10 of a millimeter. So what we're going to do is we're going to go 2.27 as our angle, multiply that by our radius, which is 6.7 millimeters, and when you multiply that together, you should get 15.2 millimeters as the arc length. So that again, the arc, so this part is 15.2 millimeters. Finally, we're going to take a look at that textbook assignment. You're just doing A, C, and E, or in other words, choosing 3 letters from all of these problems, and then doing number 14. Good luck, and we'll chat about this tomorrow.